refraction. When a beam of light is passed through certain crystals like calcite CaCO3 or quartz, it splits into two beams. So this behavior of substances showing this property are called doubly refracting or birefringent crystals. If experiments are carried out in various angles of incidence, one of the beam is found to obey Snell's law, and which obeys Snell's law is called ordinary ray, right? And the other beam does not obey Snell's law and not even found to be in the plane of incidence. This beam is called extraordinary ray. So you can see here, when we see this pencil through this double refracting crystals, we are able to see two rays, two images, out of which one is ordinary image and another one is extraordinary. Ordinary ray travels in the crystal with the same speed in all directions. It means the refractive index is not going to change, it is going to remain same in all possible directions. So that's why you can represent it like a circle. So the same speed in all directions. In other words, crystal is characterized by a single value of refractive index. That kind of ray we will call as ordinary ray, and generally ordinary ray can be represented in the form of a circle. And extraordinary ray travels in the crystal with a speed that varies with the direction. In other words, refractive index for the E ray varies with direction, and it is described by an ellipsoid. So it can be represented like an ellipse because its refractive index value changes with direction. But another important phenomenon is birefringence. So it can be defined as the difference between the refractive index of ordinary ray and extraordinary ray. We will call it as birefringence. You see, here we have ordinary ray, and if you see, this is the extraordinary ray. So if you see here, mu represents a refractive index of extraordinary ray, and mu naught is the refractive index of ordinary ray. So in this case, mu e predominates over mu naught. So that means mu is greater than mu naught, mu minus mu naught. The difference we will call as birefringence. If mu is dominating over mu naught, we will call it as negative crystal. In other case, this is our ordinary ray and this is our extraordinary ray. Here what is happening? Ordinary ray is predominating over extraordinary ray. Mu naught is greater than mu e. That kind of crystals we will call as positive crystals. So birefringence is the refractive index difference of ordinary minus extraordinary. It may be mu naught minus mu e or mu e minus mu naught. So depend if it is mu e greater than mu naught, we will call it as a negative crystal. If mu naught is greater than mu e, we will call it as positive crystal. In case of calcite or quartz, there is one direction in which there is no double refraction. So this is ordinary ray and this is the extraordinary ray. Along this particular direction, there is no separation between ordinary ray and extraordinary ray. That is, there is no double refraction along this axis. That's why this axis is called optic axis. In case of crystals called biaxial crystals, there are two such directions in which there is no double refraction. Ordinary ray and extraordinary are polarized at right angles to each other, and their actual polarization depends on the direction of propagation. One important thing to note is that even though ordinary ray and extraordinary are derived from the same beam, they will not exhibit interference when they are made to interfere. This crucial experimental observation enabled Thomas Young to guess that light waves were transverse in nature. So this double diffraction experiment especially proved that light is transverse wave.